Hi everyone. So in this video we are going to look after the indeterminacy in the structural elements. Let me go to the section. So indeterminacy, as we discussed earlier in previous lectures. So before going that, for any beam or any type of element, if a load is applied, it will produce the response. So what are the responses? It will be of internal forces. It will be of reactions. It will be of rotations, and it may be of displacements. Therefore, in a beam, when subjected to load, these are the probable responses that we can get from a beam. Okay. So out of this, these internal forces and reactions are at same position. Means it won't move. But in case of rotations and displacements, they tend to move. Since these are classified as statics and these are classified as kinematics. So the indeterminacies are based on statics and kinematics. So that's why the indeterminacy is classified into statical indeterminate structure and a kinematic indeterminate structures. So out of this we will look after the static indeterminacy in this chapter, in this class. So the static indeterminacy, the elements, what are the elements of a structure? The various elements of the structure are beams, truss and frames. So let me start with the beam. So for beams, the degree of statical indeterminacy is splitted into degree of external static indeterminacy plus degree of internal static indeterminacy. So degree of external static indeterminacy is written as R minus E minus H, where R is the reaction, E is the number of equilibrium condition, and H is the hinge reactions. H is the hinge reactions. And that of DSI, internal determinacy, which is 3 into C, which is closed loops. And for beams, it is 0. And for beams, it is 0. So this is the basic things. Let me now calculate. For a problem, you see it's a fixed beam on the left side and there is a hinge and there is a internal hinge. So there is a difference between a hinge and an internal hinge. So this is a simply supported section and this is a hinge section. Okay. So before now we need to know what are the responses. For a fixed beam, there is a vertical reaction, there is a horizontal reaction, and also there is a moment reaction. Therefore the reaction is 3. So in case of simply supported, there is a vertical reaction and there is a horizontal reaction. Therefore the reaction is 2. So for rollers, it takes only the vertical reaction. Therefore the reaction is 1. So here you can see it is a fixed. So what are the responses? There are 3 responses in a fixed beam. In case of hinge, it's a simply supported, it has a upward force and it will resist the horizontal force. So the reactions, what are the total number of reactions? Reactions is 3 and plus 2. So which is 5. And what is the possible equilibrium equation? It is 3. And H, for calculating H, the formula is m dash minus 1. So m dash is nothing but the hinge where it is a number of members which is connected by the hinge. So here it is one member, it is one member. So the number of members is 2, which is minus 1, which is equal to 1. So that is H. So we can write the degree of statical external indeterminacy as reactions, which is 5 minus 3 minus 1. So which is 5 minus 3, 2 minus 1. So which is 1. And that of external indeterminacy, internal indeterminacy is 0. So therefore the overall statical external indeterminacy is external indeterminacy plus internal indeterminacy. So 1 plus 0, so which is 1. So the degree of statical indeterminacy for this beam is 1. So next we are going to calculate the degree of statical indeterminacy for a truss member. So this is a truss member, and for degree of statical indeterminacy the formula is m minus 2j plus r, where m is the number of members and j is the joint and r is the reaction. As said ever, the reaction calculation is common for all the things, either it may be beam, truss or frames, whatever. So we will calculate. For it is a simply supported condition, so which resists a vertical load and a horizontal load. This is a roller, so obviously it will resist only the vertical loads. So therefore reaction R is equal to 2 plus 1, which is 3, and we need to calculate what is M. So M 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is a single member, you should not break as this is a single member. So the member M is 10 and joint J, you need to calculate joint. So which is 1, 2, 3, 4, 5 and 6. So where J is 6. So now we substitute in the formula. Degree of statical indeterminacy is equal to M, which is 10 minus 2 into J is 6 plus R is 3. So which is 10 minus 12 plus 3. So what is the value? Minus 2 plus 3. So which is 1. So the degree of static indeterminacy for this truss is 1. Next we will look after how to calculate the statical indeterminacy for a frame. So this is a simple frame, you can see as such. So for this the statical determinacy may be classified as the summation of external statical indeterminacy and internal statical indeterminacy. The external statical indeterminacy is written as such in the same as such of beam R minus E minus H, where H is a hinge response, and the internal static determinacy may be 3 into C, where C is the closed loop. So now we will calculate what are all the reactions, equilibrium equations we know, which is H and hinge and closed loops. So we need to found it out. So this, since it is a fixed end, it will have a 3 reactions. So this two have a 3 reactions. So the total reaction is 6, and H is the hinge, so there is no internal hinges available. So which is 0. So C is the closed loop. See, this is the closed loop. So this is C1. So closed loop. So it's 1. So now we substitute in the formula. So degree of statical external indeterminacy is, so reaction is 6 minus 3 minus 0. So which is 3. And that of degree of internal indeterminacy, structural statical internal indeterminacy, which is 3 into C is closed loop, which is 1. So which is 3. So the total degree of indeterminacy is external static indeterminacy plus internal static indeterminacy, so which is equal to 6. So hereby we have calculated all the basic elements, statical indeterminacy of all the basic elements, structural elements. Thank you.